I want to show you an experiment that you can do at home right now. All you need is an Arduino. I'm using an Arduino Nano because frankly I love them. And also a small capacitance. This is around a 10 nanofarad capacitor. And you might be able to use a bigger one, I don't really know. Try it out. But the effect I want to demonstrate is something that you might have seen before and just disregarded. You've disregarded it because your circuit probably isn't working right if you're seeing this effect. However, if you don't know your circuit's not working right, then you might actually be seeing this effect and thinking that something's happening, but it's not what you think it actually is. That sounds confusing. Let me actually show you the implementation of the circuit. Zoom in a little bit here. So here's what we see. I've got my Arduino Nano, and it's essentially acting as a voltage measurement device. We can see on this graph right here, the voltage on A0 measured in millivolts. A0 is hooked through a wire to this capacitor, and the other lead of the capacitor is hooked directly to ground. And now let me demonstrate the effect. If I take this wire, because currently we're at about 124 millivolts. If I squeeze this wire, I'm actually causing it to go down, causing the voltage to go down. I brought it down to about 80 millivolts just by touching the insulation of this wire. And mind you that there's no quote unquote magic or trickery here, right? There's nothing up my sleeve. I'm touching the insulation here, but I'm able to influence the voltage across that capacitor. In this case, I brought it down. So let's look at the board and I'll show you kind of what's happening here. So we have our Arduino and we're using the analog to digital converter on it. I'm not going to get into how that works exactly, but just know that this is what's taking our measurement and displaying it over time. And it's hooked to a capacitor. Right, we've got one lead on ground and one is hooked to the analog to digital converter. This capacitor has some voltage across it. Full disclosure, I did ground this capacitor out to try and discharge it before the video, but it sort of drifted on its own. And there's a key word, a clue that I just said there, right? It drifted on its own, rather it floated, right? This capacitor has a floating voltage on this pin right now. It's not tied to any strong voltage source. An analog to digital converter, you can almost assume is isolated from the system. And so this voltage here is floating, which means that it kind of changes with the wind almost, right? It changes with different charges being present by it, or in my case, my presence was able to change that voltage. But let's look into what actually was happening there. Oops. So I didn't touch the wire. I wasn't in direct contact with the circuit. Rather, I was kind of acting as part of a component. So we'll say right here, this is the wire, right? This is the wire inside the insulation, so the actual conductor. And then we have the insulation, which I'll just draw as a gap here. And then we have this thing. That's me, right? I'm an amorphous blob of charge, essentially, right? And I'm forming the second plate on a capacitor. And so I also have a kind of a loose connection to earth ground, but I'm also in that circuit. And so my fingers touching that wire and my existence forms a complete capacitor. A really crappy capacitor, but it is a capacitor. I wouldn't recommend putting me in any of your circuits anytime soon. But I also have a voltage, right? I just by existing, I have some voltage, we'll call it V2. And if I have a difference in voltage, I'm actually going to cause, depending on which voltage is bigger, there's going to be some current to equalize those two voltages. So if you don't believe that I'm acting as a capacitor, let me actually use a capacitor and we'll look at the effect. So I've got this kind of bigger capacitor here, and here's what I'm going to do. I'm going to first ground this out. Okay, so I've completely grounded it out. I'm going to charge up this capacitor with 5 volts. And now I'm going to just hook it into this circuit. Boop. And we saw a little increase there, right? That second, or the very last increase that we're following right here was due to the introduction of this capacitor. And also, you really do have to be careful experimenting with this, because just me being close to this circuit is influencing things. We can actually see that it's stabilized. I'm about the same potential as this capacitor right now, and so I'm not having an effect. So when you're dealing with floating pins, you need to be very careful, because I've filmed this a couple times and it's had different results. Sometimes the capacitor will go up and sometimes it'll go down. It really depends on my state as some weird ball of charge. But it's worth understanding and seeing and having a feel for how floating pins work, because you very well could run into them while debugging a system and noticing that just by being closer to something, or if you had pancakes for breakfast, that causes the voltage to change, right? It's very, very, very persnickety. And so it's always something you should be looking out for.